Hi, welcome to my latest video. Today I'm out here in the glorious February sunshine and I'm going to be investigating why my winch is not working. I've removed the front end off the car already. I didn't film that because I've already shown that in quite a few previous videos. That's off the car, the headlights are out, the hook has been taken off the winch rope so that it could go through the fair leads here, which were bolted to that sort of hole, and now I can actually see the winch. Okay, so I did a 5-part video on fitting this a year and a half ago. Okay, so it was the summer 22, okay, summer 2022, and since fitting it I've not actually really used it properly. I've demonstrated it to people, I've pulled out the rope and wound it back in at Land Rover shows and events where I've been on the 4x4 response stand. We've been sort of demonstrating winching and things like that, but I've never actually towed a car or my car. So I was very disappointed when, during a recent visit to Imber Village on Salisbury Plain, I took the opportunity to use the winch to pull 3 ladies in a Volvo estate out of some mud. They'd tried to do a 3-point turn and sort of backed off the road slightly, and their wheel ended up in the mud, and they just couldn't get enough grip to get back onto the tarmac. So I saw them standing around their car, and I pulled up and I said, oh, I've got a winch, I'll quickly pull you out of the mud. And I disengaged the free spool, pulled out the rope, put that back on, put the magic key in. Okay, so I've got an isolator switch here, and put that in, got my remote control, turn that on, and it just clicks. It's clicking in and out. So it sounds like the relay in the control box is working, but the motor is not running for whatever reason. I don't think the motor's burnt out or seized or anything, because the drum does rotate, certainly on the free spool, but this has been fitted for a year and a half. It's never actually been used properly. It's never actually exerted any sort of proper force on this rope. So the motor, I'd be very surprised if the motor has failed. It's more likely to be an electrical connection. Okay, so there are various big thick cables that go down here. Now I've used these cable glands here, which should sort of make that a sealed unit, but there's every possibility that water may have kind of run down here. When I did this project and I installed that, somebody did comment to say, oh, I wouldn't have put it that way up. Even with the sealing cable glands, I'd have put it the other way up. It was too late by then, I'd already done it this way, but in hindsight, yes, it would have been better to have these at the bottom. So water may have got in there. The back panel is a sort of kind of loose fit, so I don't think water's going to sort of build up inside here. It will drain out. But somewhere between these high current connections in there and these sort of connections here, I reckon there's a high resistance somewhere. Now the wiring for the winch is not that straightforward. Okay, so you'd think there would be a plus and a minus and they'd just power it one way to go out and turn it over to go in. It's not quite as simple as that. There is a positive connection, so we've got positive from the battery goes into the box, ground from the battery goes to the winch underneath. There is actually a terminal kind of hidden away a bit under there, you can just see, and that's this big thick black wire. And then coming out of the box we've got 3 wires, 2 black and 1 red. Now, what I'll do in a moment is I'll get my whiteboard and I'll actually draw out very quickly a quick wiring diagram rather than trying to kind of follow all these wires and try and explain it. I'll just sketch it out, okay? But this red one goes to a red sort of terminal with a red boot, and then the 2 black ones are the yellow and the black. So all in all, there are 4 big cables that go to the winch motor. Okay, so you've got sort of a positive, a negative, and 2 other ones, which I'm guessing is sort of they're kind of like control cables for forwards or backwards. So yeah, something's not connecting properly, I think, somewhere. There is also this very thin wire here. Now that is a little ground connection. It just earths the electronics in here. There's a radio receiver in here for the wireless remote, and the relay coils need a ground. So that's the ground there, and that goes off. Where does that go? That's also going down underneath here. Now you never know. It might be that wire that is not connecting properly, but the relays are clicking. So the receiver in here is receiving the remote control and the relays are clicking. So I don't believe it's that, but I will sort of test that one as well. I've already measured voltage here, just in case it was this switch, which was, had gone a high resistance inside, water had got in there, and contacts had got high resistance. So that's fine. The voltage is there and it's not dropping when I operate the winch. Okay, so I don't believe there's any high resistance here. There's also no high resistance on the battery. Okay, so we can rule those out. I've already eliminated those from the inquiry. Okay, so what I'm going to be doing is getting the voltmeter and just testing these terminals as I operate the winch, because if something's at 12 volts and then you go to operate it and it drops to near 0, that's an indication of a high resistance joint there. It just can't flow that current. Okay, so I believe that's what's going on, but which terminal it is, I don't know. If all the terminals are getting the correct voltages and the voltage is going into the motor and it's not turning, then it is the motor that's at fault. What I do then, I don't know. Buy a new winch probably. So yeah, I mean, the one option would be to try to take it apart and see what's going on inside. I don't really want to do that if I can help it, because there's probably all sorts of cogs and springs and gearboxes and everything in there which reduce that drive down to a very, very slow sort of drive. There's the planet, what do they call them, sort of sun and planet gears and that kind of thing in there. Okay, so I'm going to get the whiteboard now, just sketch this out, and Pit Lane Kitty's out here. She's enjoying the sunshine. She's going to help me do this, and I'll see if I can get it working. Okay, so I've got the whiteboard out, and I'm going to very quickly sketch out the winch wiring. Now, this will help any of you who are trying to wire up a winch and are possibly getting a little bit confused as to how it connects up. Okay, so let's draw out the winch. Okay, so I'm just going to draw that as a sort of orange kind of thing here with rope on it, with a hook there. And this winch has various connections on it. So there is a ground connection here underneath. There is also a red terminal. Okay, so let's draw that one as red here. And there are 2 others. One of them is black and one of them is yellow effectively. It's a black cable but with a yellow boot. So let's draw the black one and the yellow one here. Okay. The control box, which I will draw over here. I'll draw it quite large. I'm actually going to draw out what goes on inside that control box because that's quite important to understand. Okay, so this control box has a feed from the battery positive. Okay, there's the plus there, and there are 3 other large cables plus a very small cable that comes out of it. So that small cable is just a little kind of earth connection, so I'll just draw that in here. Okay, and that connects up to there, to that ground connection there. The battery negative goes off straight over to the connection underneath the winch. Okay, it doesn't go into the box. Okay, and there is a positive, a red cable, which goes to the winch. Okay, so let's draw that. So there's a red wire here that goes off to the winch, and there are 2 other cables, 2 other large cables that go to the winch. They're both black cables, but I'm going to draw one of them as yellow. Okay, so let's just draw the black one here, and then the yellow one here. Okay, try not to cross over too many of these wires. Okay, so these 4 all have sort of like cable kind of glands coming out, waterproof cable glands at the top of the box. So this motor is a little bit odd in having sort of 4 wires. Most of us think of a motor as having 2 wires, plus and minus. If you want it to turn the other direction, you reverse the wires over. Certainly that's how small motors work inside toys, radio controlled cars, Hornby train sets, Lego models, Scalextric cars. Those motors just have 2 wires going to them. This motor has 4, and most winches do have 4 wires going to them. Why does it have 4? Well, the reason is it's not a permanent magnet type motor. Okay, so some motors have they have 2 sort of magnets inside, and the armature, the bit that turns round, has a coil of wire. Okay, so that's a fixed magnet motor. These motors that tend to be used for the more powerful winches don't have a fixed magnet inside. They have a field winding. Okay, so inside the motor there is a winding here that I'm going to call F for the field, and there is another winding which I'm going to call A for armature. Okay, so A is the bit that spins, and the field windings around the outside, they don't move, and they replace what you would normally find in a smaller motor, which is the sort of fixed magnet. So instead of a magnet, you have an electromagnet, okay, which is the field winding. If you reverse the connections to either of these windings, the direction that the motor turns will be reversed. Okay, so the way the winch works is the armature windings are always fed the same way. So 12 volts ground, and you just enable that 12 volts when you want the winch to turn. These 2 are reversed depending on whether you want the winch to go in or out. So what goes on inside here? What goes on inside that control box? Well, inside there is a large relay. Okay, now that relay actually comprises of 4 switches, electromagnetically controlled switches. It's 2 double pole single throw relay connections. Okay, so a relay uses an electromagnetic field to switch a larger current. So I'm just going to draw that out now. So inside we have 4 switches effectively. These 2 are joined together, those 2 are joined together. Okay, so these 2 operate, or those 2 operate. One of these is for out and one is for in. Okay, so the way that these are wired up inside, you have positive here, which goes to there, and also down to there. We have the connection to the armature winding, which is also a sort of positive. It's an active 12-volt connection, and that is connected to there and there. Okay, so I'll put a little blob there to show they're connected. So what about the black and yellow wires, the field windings? So those ones, let's draw yellow now. Okay, so this one here connects to there and also to here. And then the other one, which is a black wire, but I'll draw it with a blue pen, okay, just so we can see it a bit easier. A lot of winches, they actually have a blue and a yellow wire instead of a black and a yellow. Okay, so this one might be blue. So let's draw out now this one here, and that goes to here and here. These relays are operated by a little electromagnetic coil. Okay, one for each of the operations. So if you want the winch to go in, this one is energized, those 2 make. If you want the winch to go out, this one energizes and those 2 make. Okay, and these are connected into our sort of radio receiver. I'm just going to draw that with a little kind of antenna. Okay, so let's explain what happens. Normally, when you are not pressing any buttons on the remote control, either wireless or wired, plus comes here and it doesn't go anywhere. So the winch is not doing anything. When you ask for the winch to wind out, so let's put out here and in. So when you press the out button, these 2 close. The positive here comes down through here, down the yellow, through the field winding, back on the black, and then goes through this one and off and powers the armature. Then when you reverse the direction of the winch and you press the in button, the receiver receives, it energizes this relay. These 2 contacts make instead, and the positive comes down here, down the black, the other way through the field winding, back on the yellow, and back to here and off to the armature winding. So the armature is always being fed by the 12 volts in the same direction, but the field windings are reversed depending on whether you're going in or out with the winch. That is how it's wired. This all goes on inside this control box, and all of that lot is inside the big relay module that has 4 big high current M8 threaded posts on top of it. It also has some small connections, 3 small connections for the coil energizing. So that's how things need to be wired. What I'm going to do now is get the meter out and start testing some of these cables and see what voltages I'm getting when I press the buttons on the remote control. Okay, so I've got the meter out here, I've set it to the 20 volt range, I've connected the black wire to the battery negative, and I'm going to be probing around to see if anything goes to 12 volts when I try and operate the winch. Okay, so I've turned that on with the red key there, and I'll just see what voltages we've got where. Before I do that, some of you may have noticed this plug here with another cable here. That goes off across the top of the radiator and goes to a socket on the wing. Okay, so there's a little XLR socket there. And then what I did is on the wired remote, because this winch comes with 2 wireless remotes and a wired trigger remote, I've put this plug there, an XLR triple 3-pin plug on there with a coily wire. Okay, so the coily wire really is just so that it can be stowed away fairly tidily. I actually just stick it underneath the driver's seat, but because that's coily, it can extend out to be a couple of meters long. So if I need to, I can sort of plug into there and stand well clear, or even put the wire in through the window and drive and operate the winch at the same time. I have tried this remote. Let's just try it now, just to prove. But at first, I thought it might be an issue with the wireless remote, and batteries might be flat or lack of Wi-Fi signal or whatever it is. So let's just try this. Yeah, exactly the same. Okay, so it's not the remote control. It's not the remote control. It's definitely the winch itself, or the control box. Okay, so first thing first, let's test what I believe is the positive connection to the winch. Okay, so that's this red terminal down here. In, nothing. Out, nothing. Okay, so that's, I believe, the issue. The yellow and black are switching 12 volts 0 in a slightly odd manner, but they are changing. Okay, so they're connected to something that's switching. This one here, I believe, should be 12 volts, and there just doesn't seem to be any voltage on it. So I think it's that might have something to do with it. Ooh, right. Okay, so that's probably what the issue is. This cable, where I'd sort of crimped these and soldered them, it looks like it's broken the cores off, actually. There. Well, there we go, and it's full of white oxide. Okay, that's probably the issue. Right, let's just try it. I've just got to be careful, because if this is 12 volts, I don't want it flapping about and touching anything. Let's just see if I can measure this. Get onto a bit of copper. That is clean. Right, there you go. 12 volts. 12 volts when I'm in, and 12 volts for out, and nothing in between. So, well, there's the problem. Right. It is the eyelet, the big eyelet that is on this, underneath this boot. Just trying to work out if there's any sign of any heat damage or anything like that. No, it all looks, it's a bit grotty inside, but I think that's just a bit of dirt's got in there. Okay, so that's the problem then. Okay, so quick update. What I've done is disconnected all 4 of these big cables plus the little earth cable, which is here. Okay, so that one looks fine. Out of these 4, that one's not too bad. It's a bit oxidized, but it's mechanically sound. That one is also fine, a little bit rusty, but it's okay. That one I think is, what is that? That's the battery negative actually, so that wire probably came with the winch, hence it's got the heat shield, heat shrink around it. So that leaves this one where it broke off from the eyelet. Okay, so that is the eyelet that it came out of. There's a lot of white oxide in there. Now I think what's happened is where I've soldered that, the tin, it probably isn't lead, I think it's lead-free solder. The tin or whatever the metal is that they put in solder these days has corroded. I don't think it's a kind of an electrical sort of corrosion, it's literally just got wet and corroded. These wires should have all been dead electrically for most of the time, only briefly being powered up. So yeah, so that's that one for the red. The other one was the yellow. Okay, so the yellow is in a really bad state. So that has just broken off. Okay, but look at how swollen these wires here. It's just absolutely, it's oxidized so much that it's actually swelled the insulation around the cable. And that one, you can still see the wires in the end there. So that was soldered mechanically in there, and then it's just kind of oxidized so much it's just broken off. The yellow boot has loads and loads of white gunge in there, loads of it. All the other ones are not too bad actually, but yellow one, whatever this stuff is, white powder, there's a lot of it inside there. So I need to clean all that up. I need to cut these wires. I might even have to replace some of these wires, because that I can feel that's lumpy back to about there. Okay, so I think that white oxide has got down inside there. It might be just sort of where I soldered it, the solder has kind of wicked down the cable, but I'm going to have to cut that back, and the question then is it going to be long enough? It's going to be just about enough slack on there to cut that back, put a new eyelet on, heat shrink it, cover it in grease or something to protect it for the future, and reconnect everything and see if that works. Okay, I haven't opened this up yet to sort of have a look inside. I believe that end of the cables is okay. Okay, so this is kind of sealed. I don't think water and moisture will have caused the same level of oxidization on the other ends of the wire, but I may just pop the back off there just to have a look, just to see, because if the wires are ruined at both ends, I'll just fit new cables. Okay, good opportunity to maybe use some yellow and blue cable instead or something. Okay, so yeah, so that's what I found. So 2 of these have broken off. They would have been very, very high resistance with all this oxide. That is the state of play at the moment. Okay, I think it's probably better actually if I remove the back of this sooner rather than later and just have a look. Okay, because that is just on a bracket. It's just kind of in midair. I don't know if there's actually a drain hole underneath. Don't know. Yeah, okay, I'll have a quick look inside this, I think, and just see what's going on in there. Okay, so I've just removed this from its bracket and removed the back on that. That's just screwed on. It's not a sort of watertight seal. Okay, so I don't believe any water has got in there. Slightly worryingly, there are muddy water drip marks on the inside of that, which is worrying, but in everything in here, yeah, there's definitely water's got in here. Look at all this dust in here. Oh dear. Right. Okay, well, muddy water has got in the bottom of that, but everything else is clean as a whistle. These eyelets here are all absolutely fine. They're still shiny. Okay, so nothing is oxidised, and I have no reason to believe that the sort of electrical conductivity of those joints has suffered in any way. Okay, so here we are the next day. I went to Halford's last night and I bought some battery cables. These are, I think, about 75 centimetres long, and they've got M8 or 8mm hole eyelets already crimped on the end and heat shrunk. Just in case I can't fit these eyelets through the cable glands, I bought some crimp-on eyelets, although I have since learnt that these really need to be crimped on by a big crimping machine, ideally like a hydraulic crimper. Okay, so here's a picture of one which I might go and buy, but I won't worry about buying that just yet until I actually need it. Okay, there's no point in buying it. If these fit through these, then I'll just run those along, down, and this can all be connected back up, and I don't need to worry about crimping. I think the mistake that I made when I fitted the winch was that I added solder to the crimps. Okay, so I crimped and then just sort of soldered into the kind of hole at the end, and yeah, that's just sort of oxidized. What's happened is the solder has formed a sort of a kind of like a hard interface between the flexible copper strands and then the solid solder, and that has worked and broken. I don't know quite how it's sort of actually vibrated itself and fatigued, because this was clamped down and that was bolted there, and all of this is really super solid. Okay, but somehow that has moved. It's probably not helped by water getting on it. I believe that this one here would have failed also after a while. Okay, so the only one here that's actually fine is the one that's got the crimp and heat shrink without any solder, and that's the one that came with the winch. Okay, so that's actually really been crimped flat there. That's been sort of totally crushed there against those strands, whereas these I just kind of crimped. I put it in my bullet connector crimpy thing. It's got a big setting for big crimps, but it's just not strong enough. Okay, it really needs a very high pressure crimp. So what I'm going to do today is open up this again and remove these 3 cables. The red one to the battery via the isolator is fine. Okay, there's nothing wrong with that one. Okay, it's these 3 that all need replacing. This one here goes to the battery negative, that's fine, so that can be reused. Okay, so that's this one up here. Now, one thing that I have thought about is turning that box 180 degrees so that the cable glands are on the bottom. I don't think I can do that today. Okay, so there's two sort of obstacles with that. One is the length of these cables. Okay, so these are long enough to go from inside here, along here, down to there. The other thing is, if I did turn that around, the cables would be running along the bottom there. Okay, and I think that that's just asking for them to get caught up in the rope. If they're up here on the upper surface of this thing here, then they can be held securely with cable ties, and they're not going to go anywhere near the rope. If they're down there, they could just get caught up in the rope. Okay, so I can't really run them underneath. I mean, technically I could possibly take them through the drain holes. Yeah, it's not really a good way to do it. I don't like the idea of them coming up through this hole here with sharp metal edges. I could put a big grommet there, but then you've got the cables running along the top of the intercooler. That gets quite hot, so yeah, I think the cabling needs to be this side of the winch tray. One thing I could do, and I'll save this for another day, is to actually replace these with much longer cables and take them sort of down and up and along here and down and like that. Now, longer cables will have more resistance when they're flowing hundreds of amps driving the winch. You don't really want long cables, but what I could do is get thicker cables. So these I think are rated 170 amps, which should be enough for light duty winch usage. This one here, the ones I'm replacing, it says 16 millimeters squared. Now let's just offer up, I think that's thinner. I mean, it's difficult to tell, the insulation might just be thinner. It's a similar sized cable. So this one here is probably, I think it actually was some jump leads that I cut apart, and I think they were rated 200 amp or 250 amp jump leads. Okay, so yeah, so that's the sort of cable thickness I want, but you'll notice that this one here and this one here are even thicker, and those two cables were the ones that came with the winch. Okay, so this one here that goes off to there was quite long, so I just kind of cut it in half, put the isolator on, and then used the rest of it to go to the battery positive. And this one here was nice and long, and that goes from battery negative to there. I like the thickness of these, and they will be rated the correct current rating for the winch. Okay, so I think this winch actually on the sort of inner windings, if you are really kind of maxing out the winch, it can be 350 amps or something crazy like that. Now, I don't ever intend to use the winch like that, but you never know. I might get really stuck one day, and the tree that I tie the winch to might be quite far away. I could potentially get in a situation where I am drawing that sort of current. So what I'm going to do is I'm going to look into getting some thicker cables made up that are longer, can come out the bottom and up around here. Okay, so because of the length of the cable and the fact that I can't route it behind the winch down the bottom, means I'm not going to turn this round today. There is one other thing that may cause an issue, and that's this plug coming out the side. Okay, so if that's turned round, that plug is going to kind of hit this. Okay, so the box would have to be moved up a bit, and the plug would have to come out here. It can't come out here because there's a headlight there, and there's, I think, a sort of a bit of plastic kind of like that, and the side of the headlight. Okay, so here it is clear. So that would have to be there, which means that lot would be up here. That's roughly kind of where it was previously. So it wouldn't actually be too dissimilar to how it's mounted at the moment. It sits about like that at the moment, with that plug just clearing the body of the winch. Okay, so if I turned that whole thing round, that plug would come out down here and be there, and then that could just double back. There's quite a lot of slack on that one that goes off to the remote control, so that would be okay. The little earth wire may need to be either lengthened or brought out the other side of the box, but that's easy to do. So the aim for today, replace with these wires, get the winch running, prove that there's nothing wrong with the motor, the relay, the remotes and all the things like that. And then as a future video, I'll beef up the cables even more. Okay, so we get thicker cables, and I'll buy cables with 8mm eyelets already on the end, properly crimped on and heat shrunk, and sort of swap those cables out one by one. I'll do that in a later video. Today I just want to get this working and get the front end back on. Okay, so what I've done is I've replaced the 3 old cables with these new ones. Luckily the eyelets fitted through the cable sealing glands here, and I've tightened those off onto there. This one here I've left exactly as it is. That's the one that goes off to the battery. May replace that at some point when I try and turn the box upside down, but for now I'm just going to refit that exactly as it was. These cables are only just long enough to reach across to the terminals, okay, so they won't reach if I turn it upside down, and I don't want them going underneath here, getting caught up in the rope or anything like that. Okay, right, let's get this in, get these attached to the terminals here, and I will then try this and see if it works. Okay, so this is all back together now. I need to bolt that in, but I've just put the back on and reconnected this. Everything's reconnected there, and the ground underneath with the small little ground cable as well. Put these rubber boots on as best I can. I think that what's happening is water has actually been getting down in here, and then it's quite a tight seal around the terminal. Okay, so that's basically, each of these has been filling with water, and that's what's caused all that oxidization. So I will try to heat shrink these a bit more, but I probably am going to need to just put some insulation tape around there. Everything's been liberally sprayed with WD-40, and the inside of the box has also been sprayed, inside of that plug and each of those terminals. Right, I'm going to give it a test now. Plug that in and see if this works. Ready? Good. Right, that's in, out. Okay, good. So what I'm going to do now is get this screwed in, get all this rope, or most of this rope, wound back in, and then one other thing I want to do, these sort of standoffs here are just steel and they're rusting, even though I've sprayed them with paint, so I'm going to replace those. I've got some nice stainless steel M10 threaded ones here, slightly longer, okay, because there was actually a little bit of gap between the fair lead and the front bumper and that, so I've deliberately got these made up for me slightly longer to kind of just give everything a bit of a tighter fit. Okay, right, last few things to do, and then the front end can go back on. Okay, everything's back together now. I've put the front bumper back on, fair leads back on, the winch hook, it's all back together, and the winch is now working again. I hope that video was useful. Don't forget to like and subscribe. I'll see you in the next video. Thank you. Bye.